Welcome back to the channel. So today we will be solving this important question, container with most water. It is a medium category problem and this has been asked in almost all the coding interviews. So let's read out the problem statement. You are given an integer array height of length n. Okay. So we have been given this height array and its length is n. So basically here each and every points represent the height. Okay. So if you can see here it is 1, right? The first, so the height is 1. Similarly, the next point is of 8. So the height is 8. Similarly, 6, 2, and so on and so forth, right? There are n vertical lines drawn such that the 2 points of the ith line are I, comma 0 and I, comma height of I. Find the two lines that together with x-axis form a container such that the container contains the most water. Okay, so basically we need to find which are the 2 points along with the x-axis forms a container and which can contain the most, like the most water, right? So basically to find which are the 2 points which can contain the most water, basically if we see this problem boils down to finding a area, right? Finding the area such that we find 2 points which makes a area, right? The biggest area, right? We need to find that. So let's understand this in the whiteboard. So if we see here, let's say if we select these two points, right? So if we make an area, so the area would be this much, right? Area would be this much. Why? Because if we are storing the water, we cannot take the height as this, right? The water will spill out, right? The maximum water which this container can store is this much only, right? Similarly, let's take out some other example also. Similarly, if we take these two, right, these two, the maximum height would be this 6 and not this one, right? Because the maximum water which we can store is this much only, right? And the length would be the difference in the indexes, right? The difference in the indexes. So what is the index of this? What is the index of this? So the this minus this would be the length and height would be the minimum between these 2 points, right? Minimum between these 2 points. So this is quite simple to understand, right? So let's understand with the example. So here in this problem, it is written that the area is 49, right? Let's find out how we achieve this 49. Okay. So let's consider these 2 points. Okay. Let's consider these 2 points. So what would be the area, right? What would be the area? Area will be the length into height because the container is nothing but a rectangle, right? So what is the length? Length is difference in the indexes. 5 minus 0, it is nothing but what? 4. Sorry, 5. 5 minus 0 is 5, right? And the minimum between 1 and 4 is 1. So the area will be 5 only, right? Area will be 5. Similarly, let's take other example. Let's take this one and this one, right? Let's take this one and this one. So what would be the area? So the area will be, uh, let's find the length. So the length would be 8 minus 2. 8 minus 2 is 6. And different and the minimum between 6 and 7 is 6. So the area will be 36, right? So if we like, we will have to keep on checking for each and every possible values of these things, these points, and we need to find 2 points which can have the maximum area, right? So here it is written like for 49, and if we see the 8 and 7, like the red one, right? These are making the uh, biggest area, right? So let's understand this. So one point is here, one point is here. So this is nothing but I, and this is nothing but a j, right? And if we take the difference, 8 minus 1 is 7, and the minimum between 8 and 7 is 7. So the area is 49. So this is the maximum area in which we can store the water, right? So this is the answer for this question. So how we can solve this, right? How we can solve this? So one solution is we can have the brute force approach, right? We can have the brute force approach. What is the brute force over here? we can have the two pointer, like we will have the two for loop I and j, right? I and j, and we will keep on checking. We will keep on checking the area, right, between those two pointers. So here we will check, right, 8 and 1. So what is the length? Length is 1. How 1? 1 minus 0 is 1. And what is the height? The minimum between 1 and 8 is 1. So that this is 1 only, right? The height is 1. So as of now, the area is 1, right? As of now. Then again, this j pointer will increase. J pointer will increase. J will come here, right? Again, 2 minus 0 is 2, and the minimum between 1 and 6 is 1, so it would be 2 only. So this will keep on happening, right? This will keep on happening. J will keep on going, right? And till we reach to the end, right? And this will keep on checking, and we will keep on updating the area, right? So this is the brute force approach. Let's check out the code. Let's check out the code. Let me delete this so that we can bring the code over here, right? Okay, so this is nothing but a brute force approach. So here we have two pointers, right? I and j, with the help of two for loop, and we will check find the length. Length is j minus I, and height is minimum between a of I and a of j. And we have this one variable named final area. So this we will keep on updating with each pair of lines, right? So the current area would be the length, this length, and the height, right? The multiplication of these two values, and we will find the maximum between these, right? So this will keep on happening, right? This will keep on, j will keep on going forward, and then once the j will finish, then again I will increase, so on and so forth. So this will generate each and every possible combination, all possible combination, right? All possible combination, and we will have the final answer, right, in the final area, and we will return that, right? We will return that. So what would be the time complexity and space complexity, right? Time and space complexity. So since we are iterating the array twice. So the time complexity would be O of n square, right? O of n square. And then space complexity would be O of 1. Why? Because we are not using any of the extra space. If you look here, we are simply using few variables, right? We are using few variables. You can see here, these are simple variables. So the time and space complexity are quite simple to understand, right? So let's run this. As I have written here, it will give the TLE, right? It will give the TLE. Let's run this and check, right? Let's run this. Let's try submitting this. If you can see here, it is taking a lot of time, right? See here, it is giving the TLE, right? The time limit exceeded. So how we can solve this optimally? How we can solve this optimally? Let's understand that. So if you see here, like what, ho- like where is the scope of improvement? Let me erase this. So we optimize the code by looking at the brute force approach code, right? So if we see here, we have this I pointer here and then j pointer here, right? So what we are doing, we are like finding each and every combination blindly. Why blindly? Because we know that if the area will be more if the height will be more and the width will be more, right? If we maximize both like length and height, then the area will be maximum, right? So what we can do here, we can have two pointers, one here I and one here j, right? And what we can do, we will find the area, okay? 1 7, right? 1 and 7, these two are a height, and the length would be 8 minus 0, which is 8, and height would be minimum between 1 and 7, that is 1. So the area will be 8 into 1, which is 8, right? Area will be 8. So as of now, area is 8, right? The next step would be we will like which one to increase or which one to decrease, right? So let's say here the height of one point is 1 and one point is 7. So, and anyway, like the next step, we will have to increase or decrease, like we will have to increase either this point or decrease this point. So the intelligence will be where we can like anyway the length is decreasing, right? So what we can do, we can we can increase the pointer where the height is less, right? So let's say if we increase this pointer, let's say we increase the this pointer or move this pointer. So if I comes here and let's find now the area. 8 minus 1, 7, and the minimum between 8 and 7 is 7, that is 49. The area is now 49. So this is the case 1. This is case 1 when we are moving the point I. Let's check the other case. When we are not moving the I is still here, and we are moving the J pointer. We are moving the J pointer. We are bringing the J pointer here. Let's check the area now. So case 2, this is what? Case 2, right? So the difference between 7 minus 0 is 7, and the minimum between 1 and 3 is 1, right? So the area is 7. See here, the difference. If we move the point with lesser height, in that case we are getting the benefit, right? So this is the approach basically in this like the optimized code, right? Let's understand the optimized code now. Okay, let's understand the optimized code now. As I mentioned, so in the optimized code, what we will do, we will have two pointer I and j. Okay, so I will be here and j will be here, right? And then we will have one variable final area, right? Similarly, we will like iterate each and every point, and like I will be keep on increasing in this direction, j will keep on decreasing in this direction, right? So we are finding length. Length is nothing but j minus I, right? So here we can see, and the height is minimum between a of I and a of j, minimum of a of I and a of j. And we are finding the current area. Current area is nothing but length into height, the current length into current height, and the final area would be the maximum between the final area and the current area, right? Final area would be maximum between final area and the current area. And this is the crux of this optimized code. Basically, if a of I, so here in this current scenario, a of I is less than a of j, right? So we will increase the a of I pointer. We will increase the, or we can say that we will move the a of I, like the I pointer, right? Got it? And if not that the case, then we will like decrease the j pointer. We will decrease the j pointer. This will keep on happening, and we will get our desired output, right? So what is the space and time complexity? If we see here, we are simply using one for loop, right? We are simply using one for loop, or you can say that the while loop. And we are not using any of the extra space. Instead, we are using few variables, right? So the space complexity and time complexity, right? Space complexity and time complexity. So the space complexity would be O of 1. Why? Because we are not using any of the extra space. And then the time complexity will be O of n. Why? Because we are simply just like looping through once, right? Looping through it once. So this is the space and time complexity. Let's run this. Let's run this and see if this is getting accepted or not, right? Let's submit this. See, okay. Uh, okay, we need to comment this. Let's submit it. See, this got accepted, right? This got accepted. So yes, we have solved this. You can like just copy paste this solution in your console also and go and try, right? So if you like this content, please do like, subscribe, and share the channel. And on this channel, you can find a lot of interview content, right? On DSA, PySpark, Pandas. You can find the link in the description section, right? Let's meet in the next problem. Until then, bye.